Complex Numbers, Part 1, Definitions and Description. Welcome to the Math Center. We're going to talk about complex numbers. So let's get started. This is an example of a complex number. It's called complex because, not that it's horrible, it has two parts. It has a real part and an imaginary part. Now before we go any further, let's talk about imaginary. It could be the letter J, could be the letter I. My J's tend to look like this. Regardless, right? It doesn't matter how you write it down. The key thing is to realize that it's imaginary part. And some textbooks will put the J out in front. Just out of force of habit, I put it at the end. Now this part is called imaginary because it's essentially the J is equal to the square root of -1. It's called imaginary because you can't do this. It doesn't go into your calculator. Imaginary numbers might seem kind of weird, like the punchline of a bad joke. Knock knock, who's there? Square root -1. Oh, that must have been an imaginary knock. Eh, 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 eh. But complex numbers do have a practical application. You will notice that there is two parts in the number. This gives us the ability to measure two separate things at the same time. So for example, you could measure the velocity of a car at a certain spot. Complex numbers are nice in that they allow you to measure two things simultaneously. I want to take a moment to talk about the J. So J is equal to the square root of -1, therefore J squared must equal -1. So if you see a J squared in an equation, just change it into a -1, much like this. And then we're just going to substitute and solve, and that just ends up being -4. So now let's get started working with complex numbers. So remember that complex numbers consist of a real part, which we're going to call x, and an imaginary part, which we're going to call y. And the j is there, indicating that that is the imaginary part. The other thing to recognize is that because there's an x and a y, this is what we call rectangular coordinates. That becomes important because soon we're going to be switching to polar coordinates. So if we're given this example, -3 subtract 4j, so the x would end up being the -3, and the y would end up being -4, based on the equation that we're given. Now we can sketch this. Typically we would go to the left 3, and we go down 4. So we would have that point, and we're just going to connect it to our origin, and now we have a right triangle. And oftentimes when I have a right triangle, I have to find this long side, which is the hypotenuse, which oftentimes when we're dealing with the plane geometry, we're just going to call it r. We know how to find r. If we know the adjacent side and the opposite side, we can find the r using the hypotenuse theorem. And usually the theorem is represented as c squared is equal to a squared plus b squared, but we're going to change the a and b's into x's and the c's into r's. And I don't want r squared, I simply want r. So r is the square root of x squared plus y squared. So you substitute in the numbers, make sure you follow BEDMAS. So -3 squared is 9, -4 squared is 16, and that gives you the square root of 25, which just ends up being 5. So now we have our x as being -3, our y as being -4, and our r being 5. And if we think back a little bit, x, or the adjacent side, is usually associated with the cosine. And y, our opposite side, is usually associated with sine. Oftentimes we'll have to find this little angle that is in here. We're going to call that theta. And theta is equal to inverse tan of y over x. So if you're given r and y, you can figure out x And if you're given r and x, you can figure out y, if it's a right triangle. In this particular case, we just plug in our numbers, and our theta ends up being 53.130102. You need to realize that 53.1 is just how far it is away from the x-axis. It's not telling the true location in space. You go around 180 degrees, and then you go around another 53.1. So actually, our total angle is actually 233.1 degrees. Finding theta becomes important if you have to convert from rectangular to polar coordinates, but that's a video for another day. So I hope that helped. Make sure you hit a like so I can brag to my daughter that I'm a professional YouTube creator, and I can boast to my boss and my coworkers of how many likes I get.